Early on tonight, we're going to talk about homework, and this will be a pattern for each of our classes. My goal here, of course, is to get a feedback from you as to that you've completed the homework, and that, and if you haven't, what were the issues, and if you have, what did you like and what did you not like about the homework. So really, that's where we are. Here is the homework assignments. I don't have this little pointer doesn't work here. It works fine against the wall, but not against the TV screen. But I do have. Ancient. Has everyone now have a Vectric account? And has everyone downloaded the software? Okay. Bob, Tom is downloaded. You Sam, you've got it downloaded. Okay. And the video on wood species, has everyone watched it? Pretty straightforward. American hardwoods. Okay. Thanks, Chris. That's better, I think, isn't it? Even better. I've spoken with several people about purchasing wood and how much, and I'm going to speak to that as we go through this evening. I want to make sure there's no lingering questions there.
You don't show up on the video in this lighting.
Okay.
The screen does. I don't know if you want to be on film or not.
I think we'd better be on the safe side there.
Okay.
Okay. Still
Right
good?
there, right there. You can barely see him.
Okay,
Let's leave it here. Can everyone see the screen?
That's the important part, Joe.
This is a copy of the page of homework assignments you have, so just pointing to a line, really. We've got one man here that wants to build 2 boxes. So where I say to others, get a full, twice what you need. For the 3 boxes, get 3 times what you need. Okay? All right. Okay. The project files. Now, has everyone been able to download the project file and get to the point? I'm talking about the people who've got the software. You've been able to load a project file and see the data, see the controls, the icons. Okay.
I've got half that. I've been able to load it, but, well, this is what I got.
Okay, so we got an issue here. Bob, you haven't loaded the software yet. Chris, you're okay with the software? Okay.
Apparently I am now.
Okay. And, okay, there were three videos, all from Vectric employees. And has each of you watched those 3 videos?
Yes.
Okay.
Yes.
And the third one in sequence here, that's where one of the presenters went through the complete build assign process. Pretty straightforward. You're able to follow along? Any issues or questions?
One of those links did not work at all.
Okay.
And I think it was the third one down under Vectric Videos.
This one?
It said could not find the file.
Okay. Well, I will follow up and get you a link that will take you to that video on YouTube. Okay. Instead of going through Vectric, we'll use the YouTube version of it. That's the video that shows the complete process of creating a sign. Okay. And the last video, of course, was the guy talking about digital design. Did everyone make it through that? It went for about 20 minutes, as I recall, and he does a very thorough overview of describing the industry. You were able to see that one? Okay. Anything you didn't like about either of those? Anything? Okay. All right. And then the last, of course, was the link to the online documentation for VCarve Pro. Did everyone follow the link and see the beginning of the documentation? We're going to use some of pages from that site as we go through the data. Let's see. Okay, so homework. Everybody satisfied? Sorry we didn't do the full load of homework for session 1 that we've done in previous classes. But I promise we'll make it up. We'll make it up. Tonight is a combination. I want to do a tour of the wood shop. I want to demonstrate the tools, each of the tools that you will need to use to build a CNC blank. And this walkthrough will be a safety demonstration for those tools. Chris is going to help there describe the tools themselves as we go through. Thank you, Chris, for volunteering. And then I'd like to keep the walkthrough right around an hour. I can't afford any additional time because I'd like to come back and use the software to demonstrate to you how the software is managing each of the components of the medium project box. So we're going to, and how it was designed, we'll talk about how it was designed, what each of the vectors in the file represent for the design. And we're going to set it up where next week we can talk about tool paths for each of the individual cuts that you'll make to create the box's components. Okay, so that's really tonight's agenda. And this slide is going to say that. Oh, I didn't mention terms and basic graphics, but we'll be talking about that over and over with as we go through the course. Goals, specifically for tonight. I talked about the 4 goals last week, but tonight, of course, be safe is the major topic. And when I say be safe, I mean that in every step we make in the wood shop, we're going to protect ourselves and protect the others that use the wood shop. It's our responsibility to do that. First of all, if each of you should have a copy of the procedures manual. Okay. Now, just to let you know, I have a soft copy, and I will email it to you, Roger. This is an item that we typically email when a new member is first joining, and I'll take care of that. It does specify safety procedures. It does specify certain tools and how they can or can't be used until you've gone through a safety demonstration for that tool. And just for your information, there are some thoughts to revising that book right now. I don't know exactly where that plan stands, but maybe by the November Woodworking Club meeting, we'll be looking hard at a new manual. I'm picking a number out of the air.
An amended manual, a modified manual.
Modified manual, okay. Okay, always use eye protection. any kind of eye protection is good. The specifically designed woodshop eye protection is better. So anytime you're operating a tool or doing any kind of work, have some level of safety glasses. We don't have any specification as to the quality of those glasses written down, but I would encourage you to make sure that they would protect you should some item fly your direction. Perfect. Good. Step by step. Dust protection. I'm going to touch on dust protection when we do the walkthrough for each of the tools, okay? Always have the dust evacuator for that tool live when you're using that tool. No exceptions. No exceptions whatsoever. And don't fuss at me if I forget. Also, a safety mask is recommended, and plan to use hearing protection. When I say plan to use, that means know where it is and where you can immediately get it, because you never know when somebody's going to turn on one of the very noisy tools. Keep in mind those safety features, and as I close this particular cell, we are responsible for the cleanliness of our shop. You'll see signs all over the shop that says, leave it cleaner than when you found it. I'm here tonight to emphasize that as we step forward. Let's keep it really clean. Let's minimize people fussing about how dusty it is, okay? Okay, with that in mind, let's go take a tour. Rosa's going to bring the hand camera and she's going to try and capture the audio. Okay, it's 17.75 times 14.25, and then divide that by 144. And that gives you the board feet needed for the CNC blank. I'm going to pass this around. This happens to be a CNC blank as it comes out of the machine. And you can see some rough cuts, but what you see are rough cuts. It's rather easy to clean up with a little bit of sandpaper. And just with a little bit of work, those parts will become what I demonstrated last week. And we'll bring those boxes back in next week also. Okay. When we went through the steps in the classroom, in the wood shop, when we went through the tools in the wood shop, I covered a process that consisted of cross-cutting using the sliding compound miter saw, then using either the joiner or the planer to get the first reference surface, okay? And then I discussed using the planer to reduce that final product to the size that you're going to use to glue components together to form the CNC blank. And I say that clean up the glue joints and then let me back up just for a second. I say use the planer to approach the desired thickness of the CNC blank. Now, this is 3/8 of an inch material I'm circulating around the room. There are two files available on the website. One is a 1/2 inch material, and the other is 3/8 inch material. Files that intend to use 1/2 inch and 3/8 inch material. But I recommend that you not plane it to a 1/2 inch on the planer. Plane it to something more than a 1/2 inch. Glue that together and have a little allowance for the potential that the seam between two boards is not going to be perfectly flat. And with that small allowance, use the plate sander, the drum sander, to obtain the exact thickness. As we begin to talk about design details tonight and tool paths next week, we see that the exact thickness is essential. And we're going to talk about alternative ways of calibrating the machine based on whether you have that exact thickness material or whether you have something a little bit smaller. Okay, we'll talk about that next week. And then use the plate sander or the planer to obtain the exact thickness. And I sized this CNC blank so it is feasible after you glue parts together to take it to the planer, and at 1/8 of an inch at a pass, narrow it down to the thickness that you desire. Okay. Repeat from last week. Raster graphics and vector graphics. Raster graphics, of course, is nothing but a picture, and there's very little intelligence in a raster graphic file. Easily reproduced and copied. Nice. Vector graphics is where you have a beginning and end of, and the type of vector for each. Back up. In vector graphics, you're going to have the exact dimension of every line, box, circle, star, oval. For every object in your design, in vector graphics, you're going to have the exact dimensions. Now, we have several here that have an IT background, information technology background. You can think of a vector file as a database where each entry in the database contains all of the data for that particular vector. Okay? As we step forward thinking about vector graphics, I mentioned last week that for vector graphics in a given three-dimensional space, you're going to know the beginning of the vector, you're going to know the shape of the vector, you're going to know the exact size of all dimensions of the vector in that one database entry. Okay. Think of a vector file as just a database of vector objects. I talked last week quite a bit about three-dimensional space. Three-dimensional space, we normally, in school, of course, we look at a two-dimensional diagram. We've got the width of it, you got the horizontal width of it, and you've got the vertical depth of it. Well, in three-dimensional work, we also have to consider the height of it. We consider the width, the depth, and the height. And we call them X, Y, and Z. And it's becoming sort of standard that we color code them from that point of view. We're going to color code the width in the red direction. We're going to color code the depth in the green direction, and we're going to color code the Z or the height in the blue direction. And here I show on the left the graphical representation of that three-dimensional space on the Fusion 360 product. And on the right-hand side, I show the graphic that's used within the Vectric VCarve Pro and Aspire products. Of course, tonight we're focused on VCarve Pro. And the terms, you saw this same slide last week. Vector files are typically stored for Vectric in what we call the CRV file format, and that's proprietary to Vectric Corporation. But Vectric can also import files from other systems. It can import DXF files or AI files as an example. And for three-dimensional work, the Fusion 360 product, the F3D is the file format. It's called Fusion Archive file, Fusion Archive format. That's F3D. Again, CAD terms. We covered this briefly last week. A vector is simply a line on paper, whether it be a circle, whether it be a square, an oval, a star. A closed vector, a circle that has a beginning and an end that touch each other. A square, circle, oval, all could be closed vectors. A tool path is the steps that will tell the tool how to move the cutter head, or in the 3D printer case, the extruder to deposit a little bit of plastic. The tool path is the steps it will go through in order to, and I'm going to use the words, trace that vector into the wood. Sort of a glib statement, but that's really what we're doing. For the Shark CNC router, we're going to create files in the TAP file format, and that's just the next wave Shark name for the G-code file that it will accept. X is the horizontal direction, Y is the depth of the object, and Z is the height of the object, X, Y, and Z. Okay, all a refresher from last week. And now, of course, let's get into the files that you have downloaded and loaded into your copy of the VCarve Pro software. What you see is the medium box file loaded into my copy of VCarve and represented here in this PowerPoint cell. Last week I pointed to the menus across the top. These are the typical Microsoft menu structures, beginning on the left with the traditional file for loading and saving files. We'll talk about many of these during the night and during the course. I have a set of controls off the top, over the top of the screen. These controls individually have some amount of individually determine how vectors in the workspace relate to each other. One of these tools we'll use quite often is called intelligent snapping. And that just means when I position a vector near another vector, they're going to snap together so that they are truly right next to each other. And we'll talk about the details as we go through the material. This is the area for the workspace. And I am showing here the two-dimensional view. There is also a three-dimensional view available, and we'll talk more to that next week. But continuing to talk about the two-dimensional tools, I have an area towards the left of the screen where each of the icons represent a tool that will allow you to draw in the workspace or manage a vector that's in the workspace. Then on the left-hand side of the area, there are several tabs that are used to determine which of the tools that overlay each other on the left-hand side are currently visible. As you can see by the black area, that the design tools are currently visible in this space. And we will, before the class is over with, talk about each of the other 4 tools. Within the design workspace or the design tool space, the very top set of the very top set of controls, an icon and a control is used synonymously. They're the same. These icons call up a particular screen, which could open a file using the little file folder. The most important one is to the left. And I mentioned last week we commonly refer to it as the setup window. The setup window fully defines to Vectric the size of the workspace and how the size of the material in your workspace and how you want this material to be used by the software. Now there's 4 rather straightforward controls. First of all is the size, and I mentioned the size several times. When you open your copy of the software, immediately open that particular icon, that particular window, and you'll see the dimensions that I spoke to earlier. Also, whether this is a single-sided job or a double-sided job, it happens to be a double-sided job. Okay? I've got dimensions, I've got decorations on the end on one side of this wood. So we're going to tell the software that it is a double-sided job. The third thing we are going to do is, for double-sided jobs, we're going to tell it which way it turns. Okay? Now, you can either turn it this way, or you can turn it that way. So there's a control there to determine which way you're going to turn it when you finish carving on one side and need to move to the other side. And I tell it that information by the placement of alignment holes. Placement of alignment holes. Notice here I've got one on each side, so that really means that I'm going to turn it over this way. Okay? And these alignment holes are going to make sure that any cuts that are made first on what I'll call the back of the material, okay, any cut here is going to line up with a corresponding cut on the front of the material. Now the alignment holes, when I create the alignment holes, I specify a tool depth beyond the 3/8 inch material. So I go down about another 3/8 of an inch into the spoil board, and then I use a little dowel of this hole size to align the wood after I turn it over into the, okay, so that setup is crucial. When you use the software and you ask the software to create a new design file for you, the software will immediately take you to that setup window and demand that you give it the specifications that I mentioned, and there's a couple more that we'll talk about as we go through the material. Okay, the setup window. I'll show it a little bit later. Okay. There is a set of icons here their function in life is to draw a line, a circle, a square, to actually create something. And thus this area is called the Create Vector set of tools. If I go down, there's a set of tools here that intend to in some way move a vector but not change it. Okay? A good example is on the left. I can use a tool here to precisely locate a vector where I want it. If I keep going down, there's a set of vectors here that will in some way change a vector. In some way change a vector. And Vectric has chosen to include 3 icons there that specify the type of selection I want to use when I point at a vector and I want to do something with it. And there's a straightforward touch and select a vector. In that mode, I can select one vector or a group based upon how I draw a box around a group of vectors. And if I draw from the left to the right around a set of vectors, I'm only going to select the vectors that I completely surround. Okay? But if I draw from the right to the left, any vector that's inside or touches the selection line will be included in that selection. Okay? We'll talk about that several times to make sure everyone's got that straight. If I go another icon here, it's going to select the vectors in such a way that I can move it, and that's this one here. And I manually move it, with the mouse. And then there is a vector here that will flip me out of a simple draw a line mode and put me in a mode that we call node editing. And in that mode, there's going to be controls along the vector that will give me some level of control over that vector. And I'll demonstrate that tonight. And then I've got a set of controls here that their function in life is to duplicate vectors. In other words, with these tools, I can draw a pretty little heart and then arrange that heart in a circle of hearts, duplicate. Call it duplication. They call it offset and layout. And then last, I've got a set of 3D modeling tools that I can use to change aspects of a 3-dimensional model that I've pulled into this product. We'll talk about them in detail on night 6 of the class, and not before then. I mentioned the tools up in the corner that I can use to snap vectors together. And as I begin to walk away, I want to point to the vectors that we will, I want to point to the controls that we will need to use to modify the box. The first one is supposed to be the circle tool. No, it's supposed to be the line tool here. It's called the polyline tool. The second one is the circle. We will be manipulating circles as a part of the design. Here is the tool we'll use to select vectors. Here's the tools we'll use to switch to node editing mode. And here, of course, to select in such a way that I can move the vector. The tool I pointed to earlier, we will use that to precisely place a vector within the workspace. There's a tool next door that I can take any vector, a square, a circle, a rectangle, and I can change the dimensions of it using this tool. Here's a tool that I can use to double check that I'm seeing correct here. I can use this tool to twist a vector some number of degrees. It's common to flip a box or a rectangle, flip it 90 degrees, so it's in a different relation to other vectors. There's a tool here that I can use to mirror a vector. And if you look over at the dimensions of the end panel here within the workspace, they are identical. And in actual fact, I used the mirroring tool where I could make changes to one, delete the other one, and just mirror it so that I've got the two that I need for the design. And the last is a tool for centering. I can use this tool to select vectors, and I can center them relative to the workpiece, or I can center them relative to another vector. And the centering could be XY centering, or it could be X alone centering, or Y alone centering relative to another vector. I mentioned earlier that when a vector such as a line or a circle have a starting point and the ending point, and when they are the same, that can be considered a closed vector. There's a tool here that if you are manipulating multiple vectors and you want them to be a closed vector, I can select all of them and use this tool to join them together to where the software thinks of it as a closed vector. And this might be the last tool. There's a snipping tool. And with a snipping tool, if I have a vector that's not perfectly joined together and there might be a little tail hanging off of it, this tool will remove that tail off of that vector. And last, I was close. There is a tool here that is designed to take me out of design mode and flip me into the manufacturing mode, the toolpath generation mode of the software. And so that's where we will start next week as we talk about toolpaths. We'll talk about the switch over from the design mode to the CAD mode.
Is there an undo button?
Control Z.
Pardon?
Like most Windows software, Control Z will step backwards, and it's a pretty deep step back.
Also,
Sometimes,
not the last keystroke.
no, it's in number, and you got to be careful because you can go back further than what you want to,
Right.
and then you got to figure out what steps did I make,
So
and
the snipping tool may be the best tool to use for a minor mistake.
if that mistake is an extra line, yes, but not necessarily. There's other mistakes where that snipping tool wouldn't do the job.
Okay.
Okay, we've talked about the medium Paradise box. We've talked about the fact that it's an easy project. It's really does not require sophisticated woodworking skills. You don't need the motor skills of a carver to build the medium Paradise box. Simple box structure, easy decoration changes. The single blank provides the 5 items that you need, and you combine that with a 1/2 inch, such as MDF, for the bottom, and you've got a box. You can fit the planer and the drum sander. I mentioned earlier the options on thickness. And now, it's the end of the PowerPoint show, at least until we talk about homework. Paul, do you have a question?
Yeah, I noticed that you provide the file that contains the actual CRV, the vector drawing and the whole thing. All we really have to do is load that into the machine, put our blank in there, and run it. Could do that.
You could do
Is the
that.
idea, though, of the class to start out with a blank sheet of paper, screen, and rebuild essentially what you've got in the file? Is that what you're hoping?
I actually, not quite. Not quite. Almost no. It's been my experience over the years that nothing is created from scratch. Nothing. And why do we really want to create something from scratch? We need to take a look at what we have and say, is that really what we want? And now let's go about enhancing it to the point where it serves my purpose. That's really the intent of the class, to give you the tools where you can first make the decision how you want to change it, and then go through the steps to make that change. Chris, you had a point?
And to reiterate what Joe said, that's exactly the point. For example, I'm going to take not the Paradise box, but the marriage box, and modify it for my son and his wife. Something that Joe made.
That's night 6.
I've been around this class for a while, Joe. So I'm going to be doing that. Secondly, after this class was over initially, I did on my first box, first 2 boxes, I didn't use a very nice box. I did a complete design from the ground up. So I agree with Joe 100%, but the class will also give you the capability. I made a box for my granddaughter who was rowing at Stonebridge, and a box for my grandson who was in basketball in junior high school. The basketball images with their names on it. So
I'll split the difference with you. You started with the structure of the Paradise box. You changed the dimensions, and then you did a completely new design.
correct, but I started with that. Good point, Joe.
Okay, and really, in industry today, that's they could create a new dimension. When was it? 20 years ago, called the Segway. It went bust. Okay, it was just too new. People didn't know that they wanted it, but there's been many modifications of other products that have been phenomenal successes, and that's really where that's the reason I put the class together from this point of view. Let's figure out how it works right now, okay, and then figure out how you want to change it. And let's look at the tools that you need to do those along the way. So give me just a second here to switch over, and we're switching over faster tonight than last week. Just okay, let's open let's say the 1/2-inch Paradise box, okay? Just because I suspect most of us will be putting together a 1/2-inch box. Pretty much what you saw earlier. This is live. When I look at it, the first thing I want to do, like I asked of you, is to take a look at the setup screen and look at the controls that are available to you to tell Vectrix about your project. I said single-sided and double-sided, that's a selection. There's also a rotary selection which I had not mentioned. We don't have that ability right this moment in our wood shop. The dimensions that I've talked about, whether I calibrate from the surface or I calibrate the Z-axis from the machine bed, or I should say the spoil board surface. And right now the file is set up to calibrate from the material surface. And week after next, we're going to talk about alternatives and the pluses and minuses of each calibration step. I'm going to talk about the XY datum position. This is one I missed when I had the blank in the wood in my hand. Somewhere on this piece of wood, the software needs to know where the 0 point is. We know we're calibrating from the surface. So the surface and the bottom left corner of the material is the 0 position of the project file that you'll open. Now anything to the right of that position is going to be in the plus direction. Anything above that is going to be in the plus direction, horizontally and vertically. And if I go the other direction, it's going to be in the negative direction. And let's see, I mentioned about flipping it over. Here's a control to determine which way you're going to flip it. Okay, I'm going to OK out of this, and it's going to trigger a routine that's going to completely recalibrate any tool path that's already been created. And here it's telling me that one of my tool paths are going to cut into the spoil board beneath the bottom of the material. And I need to give it an OK, saying that's OK for this purpose. And at that point, we've recalibrated all the tool paths that have been prepared for this design. I'll come back to several other controls, but before I do, let's look at the information that you see about the design, and let me start by turning it all off. Now, with those actions, I have turned off each layer that was created in the design. Now, a layer is simply a grouping of vectors that mean something for a particular purpose. And I can have as many layers as I desire for the design that I want to put together. Now, for the design, here are the list of the layers. And let me start, first of all, by the profiles. And I want to turn on the profile layer. And here I show the outline of the top, front, back, and the two sides. Okay. Top, of course, up here. Box front, box back, left and right, or vice versa. Those are the 5 components. And the name of the tool path, the name of the layer, I've chosen to choose a name that's similar to the name of the tool path we will use to cut out the components, and that is the profile tool path. Okay, let's add to this the joints. Since we worry about box structure first, the joints are going to appear when I activate the joints layer. Now, the first thing I see on this side of the workpiece is the U, the mortise that's going to hold the front and the back and the bottom. Okay? And if I turn it over, there are what I called last week the rabbets that intend to add additional gluing surfaces for the bottom of the box to fit into the front and the back of the box. So the one here happens to be the front of the box, and the one at the bottom happens to be the back of the box. Okay? Now there are other layers. There are other layers, and ignore the zero plane that's there by accident. I mentioned alignment holes earlier. Alignment holes that are needed to keep in sync between the back and the front of the workpiece. So there, and they happen to be approximately 1/4 of an inch. Now keep in mind I'm using 1/4 inch dowels, and so I have enlarged the size of the hole just a little bit. They're 0.26, so that makes it easy to slip the dowel in and out. Okay, at 2.5 I found that just too much work. What else do we have here? Last week I mentioned a chamfer design that's on the front and the back, on the front edge and the back edge of the box top, and on the top edge of the box front. Now a chamfer is just a 45-degree angle sliced across that edge, getting rid of the sharp edge. So if I turn on the chamfer, I see in the background, since I'm currently looking at the back of the box, I see in the background green lines. And that's the bleed through from that side of the box to the back of the box. Now I can't access the bleed through from the back of the box in this example, but it's nice to know where they are. So when I turn the box over, I can see in the black solid lines a rectangle for the front. That was been the back, and here's the front of the top, and here is the top. Oh my goodness, there's a mistake there. It's not quite overlapping the sides. So if I run a tool along there, because the tool's are round, I'm not going to fully cut to the edge of that profile. So my goodness, what am I going to do? Let's take that vector. I've got it selected. I did it with, right now I'm in this selection mode. So I've got this vector selected, and you heard me say earlier that there is a tool I can use to make a change in size of any vector. Here's a rectangle. I'm going to choose the tool. Notice it says set size. The name of the tool is set size. That rectangle is currently 9.7733 inches wide, and I actually need it slightly wider than that. I need an overlap on each side. Let's say 1/4 of an inch overlap on each side. So I can go to this tool and I can put my cursor in that box. I can say plus 0.5, let's say 0.5. And since this tool is currently working from the center of the object, when I make the change, when I do apply and make the change, that rectangle is going to be 1/2 inch longer, and it's going to add 1/4 of an inch to each side. So let's go ahead and do that, and you can see the vector change. Okay? And I want to save that right this moment. Because that, go ahead.
Going back to your list names for your layers, when you pull up a blank, do you have to name each one, or are there pre-names?
They will give you default names.
Default names, okay.
Very, very, very appropriate names like 1, 2, 3, 4, and 5.
And you can rename them?
Yes.
Okay.
Okay, so I made my first modification to this design. Pretty straightforward. Let's go back to the layers. There's an interesting one here called decorations, and 2 others, pattern 1 and pattern 2. Let's go to decorations first. Now, just like I said, decorations, there are, for the box back, the decoration includes a simple rectangle line. It's going to be created with a V-carve, and with a 90-degree V-bit, we're going to come along the center of these 2 rectangles, the center between rectangle inner and rectangle outer. There's about 1/8 of an inch space, and I'm going to run a V-bit around that to draw a box on the back of the box back. And in the bottom right-hand corner, there's a symbol that I use for the products I create called Mr. G. Now, I'm assuming this is going to be Sam or something you will change for your design. And then if I look at the, I see the green bleed through here. Let's flip back over to that side. And I see, can you read that upside down?
That's downwards of Virginia, Curtis.
2025.
You look at it like this. It basically says this is a box made in this class. And it allows you to add your name and whatever date you want to be precise with. And notice why it's upside down. Okay? It's upside down because it's on the bottom of the top. And when you raise the top up from the hinge position, you're going to be able to read it. Okay? Okay, that's common for the other designs that are potential for this box. If I, let's flip it back over, and let's go and let's activate pattern 1. Now, pattern 1 is the what I call the chip carving design. You saw this pattern cut into the boxes we displayed last week, right? Pretty straightforward. Okay. Let's turn that pattern off, and let's turn.
Can I ask you a question? Will the software catch that you have cut into the pattern that's on the other side? Because I see right here that you've got holes through there.
Thank you for finding that.
You're welcome.
Thank you.
QA guy.
I assure you that was not a part of the design. Okay, and I'll tell the story. I'll tell the story here in about 3 minutes. I cut this yesterday, and my first cut for that material, for that, was a disaster.
Oh.
I royally messed it up. Okay, and I had to fix it. So in fixing it, I created a slightly improved design and just cut it a little bit deeper.
Okay.
Now, I haven't done any damage. I can still create the box, but not as I originally intended. So mistakes do happen.
Right. Well, now, in looking at this, the top and the bottom are not exact sizes. Is that because the top is going to have a little bit of an overhang?
The mortises, yeah, here.
Down inside the edges of the.
This came out for the joint layer, and the design of the box has the end of the front and the back. The tip end functions as a mortise to fit into here. Now, it's a perfect question because the size difference between the top and the front and the back is exactly the depth of the mortise that's in the ends. Exactly the depth. Now, I've done this several different ways over the years. I've made the mortise a little bit shallower so that I've got some excess space between the box top and the sides, making a smooth opening. And I've done it exact like this design provides. And should I not be able to truly fit the top in the finished 5-sided box, I've had to go to the sander and take a thousandths off the edge of the top. But that's all part of the finishing, the fitting process. So for this design, I've kept them identical depth. The depth here is the same as the difference between the two dimensions. And we will, if we keep these dimensions, then we'll have some minor touch-up on a sander when we finish the box.
Could you also put a bottom? Because it looks like you might have space.
I tried.
Fit?
No. I would have had to have made this piece longer, and it would have been a little bit more waste overall.
Then on the bottom then, right now, and I'm just eyeballing this, but the mortises on the side would imply that the sides go clear to the bottom of the mortise. Then does the bottom itself then just rest between
The bottom
sides?
itself is going to fit into the rabbet right here.
Okay.
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 And you'll see that in the knockdown box that I'll bring next week.
My
Paul?
question, I would follow up on that, the depth of the cuts on both sides. Will it catch that you've got a cut through into the other side's design? You follow what I'm saying?
I
Depth-wise.
think he adjusted that.
Because of the mistake on this side, I have not, the correction did not change the depth here.
Right.
Okay.
But will the software catch it and say, hey, you're going to see...
The software would not catch it, but there's really nothing for the software to catch, because I'm satisfied that I can build this box.
Right. I'm just saying, if I didn't want light shining through or whatever,
Okay.
it's not leak-proof or whatever.
The glue is going to flow through. That's a fact.
The software is not AI. It's not going to correct mistakes.
Good point.
We make in the design.
Correct
If
point.
we make a mistake, you gotta correct it. That's one of the reasons I said last week, my first box was made out of soft pine, because it's really cheap.
We provide in each of the files two base designs, Profile 1 and Profile 2. And when you do the final cut, if you do not make changes to the design structure, you'll have the choice. Which design do you want to use? The wavy pattern you saw on one of the examples from last week, and we can easily turn it on and off as we need to.
So does the wavy pattern have less depth than this pattern?
Correct, it does. Yeah.
Okay.
Yeah. The wavy pattern is available on one of the boxes in the wood shop. Okay, we have seen the complete structure of the medium Paradise box. Okay, and we've seen it for the 1/2-inch version. Now keep in mind that for the 3/8-inch version, there's going to be some structural differences. Notably, the distance between the top of the side and the top of the front is going to be, they'll be closer together in the 3/8-inch box. Okay, this is a 1/2 inch. There in that design, it'll be 3/8 of an inch. And there's, of course, when we get to tool paths, you'll see that the 3/8-inch box is going to have a 3/16 mortise depth, where here we have a 1/4 inch mortise depth. Okay. Okay, what we've accomplished. We have identified, using PowerPoint, the tools that you will need to use to make modifications to the box. Okay, and we've identified here in the live several tools, and we've shown how those tools are used. In other words, we've taken the resize tool and we've made changes to a vector using that resize tool, and we've taken a look at the setup tool that you're going to use to define the workpiece to the software. I think we've got a good overview, a good start. And now with the homework assignments tonight, and again, back to the PowerPoint. Now for the homework assignments tonight. There's a company out there that does Vectric tutorials named, and that name just slipped out of my mind. Everwood Creations. Everwood Creations, there's a young lady that's going to go through every single tool, design tool for Vectric version 11. Yeah, Vectric version 11 in her video. So you will see the controls available for each of the design and other tools in the 3D in the 2D design software. That's these list of videos. There's another CNC Machine Fundamentals video by the same presenter that did the introduction to CNC. And he's going to talk more about bits of a CNC machine. And then I have a series of videos that focus on the manual steps you'll need to get a flat board and to join boards together to get the CNC blank. So those are the homework assignments. There's probably an hour and a half of video for homework this week. We've got a couple of issues outstanding. Bob needs to get his software loaded. You have to look at software, look at homework for session 1. And spend a minute or two with me as when we wrap up here, and let me make you aware of the website and the download and the material that's available, okay? Jack, you're familiar with the website? 2025. Is that, okay. Pardon? I need to, the woodworking manual, and I'll send it to everyone. It's a soft version. It's a PDF file. As we think about wrapping up in the next minute, any straight yes or no questions? Anything? With that, again, thanks for your attention. We look forward to seeing you next week, where we will heavily focus on toolpath generation. Okay. Okay. Fine detail work, and when I'm building a box, I will often use it for some, like I say, some detail sanding. Okay. Okay. Here, let me. Yeah, right here. Okay.
I didn't use that tool, obviously.
It's my understanding that the drum sander is used primarily for very, very fine finish sanding?
It's used for very thin sanding, but it's not necessarily fine sanding. We can load it with several different grits of sandpaper. Right this moment it has 80 grit. 80 grit with the goal of quickly taking whatever's needed off of here to get rid of glue lines. Okay. The loading the sandpaper is a pretty straightforward task, and if you need something finer, contact me or one of the other officers, and we'll do it.
That's what these are for. You go to 220, grit sanders with these, and we've got a lot of these tools. And all the sandpaper is right here. And again, when you get your individual training, we'll show you this stuff.
Okay.
This is just to
Jack?
start the safety issue.
Jack?
I forgot, what is that, the glue will damage the sandpaper?
If you don't clean the, we're going to talk about gluing in another session. Glue is going to squeeze out, and it could bead up. And clearly you're going to want to take off any beading you have with a manual tool before using the sander. But I'm going to eventually this board will go through the sander with the glue that you see here.
So not anything.
No, nothing any thicker than that.
One of the videos you'll watch on flattening boards, he talks about gluing, and then give it, and you'll see it. The glue drops will come out of the top. And he says, give it about 45 minutes, and all you do is take even a credit card.
Okay.
And it comes right out.
Let's use the time for any quick questions. Anything with a yes or no answer? Did I miss anything?
Only comment. Joe pointed out this dust collector is for this wall. That dust collector is for those. That dust collector is for the back area, the bandsaw, stuff like that. Before you use it, we recommend get this 4 or 5 times. What this does is it scrapes this barrel and drops the dust into the collector. Same thing with this. And also, when you leave, you take the vacuum, you take the vacuum, and this will go throughout the entire. When you go it out, clean up your mess. Because it really is true. A clean workshop is wet lights to say is a safe workshop. And the only other thing I wanted to mention is that there's an agreement within the workshop that morning hours are dedicated to quiet work. The wood carvers are usually here. If you want to come in and do design work or stuff that doesn't entail loud machines, AM is fine. The afternoon, it's the woodworking. If you want to come in and use the plane of the saw, etc., that's the afternoon. The evening is for finishing work. You come in, if you need to, if your box is done and you now want to put a coat of wet stain or whatever on it, come in at night. Now, two last items. Let me figure out. Oh. We have jet air filtration systems. If you're creating dust, turn it on and set it for about 2 hours when you leave. It'll filter the air. If, my last comment, Joe, I'm sorry. I know you want to get out of here. My last comment is, if you are doing finishing work, over here, there's a venting system that will suck everything out to the outside. You turn this on for a couple of hours, and it'll get the aromas and the odors out of it. And Joe, that was it.
Okay, one follow-on as we close down here. There's also a general agreement that we will not do spray finishing in this room. I found it's very successful to use the outside area, do the finishing out there. I take a stool out and rig up a flat surface to do the finishing on, and then at some point in time, using gloves, bringing that material back in to dry overnight. And then, like Chris says, make sure the exhaust is on. You had a question?
Spraying, like spray paint stuff, like put it in a cardboard box to make sure that it doesn't drift.
Absolutely.
And then the other question, on the cleanup with the vacuum, how do you handle the saw blades? Do you use like a soft brush first to brush
We
on
a daily basis, we recommend that you just vacuum off what you can see. And we'll talk about cleaning the table saw in detail. We need to clean, there's a big bucket that's going to fill up with dust. We need that cleaned out at the end of every session. Yeah, cleanliness, cleanliness, cleanliness. Okay.
Joe mentioned gloves. They're right here. This thing, and it says gloves on the outside, so you should be able to find them.
Okay.
If you need them.
Okay, with